here I was thinking I was crazy for saying electrons breathe. And then I watch an animation of an electron interacting with the Higgs field and changing handedness exactly like I say it, I said it does. So I'm not that crazy, right? For saying this, like we already think that the particles interact with the Higgs field, and this interaction with the Higgs field is what is causing the flip of the handedness, and there is a quote unquote balance. I mean, I don't remember what the term was used in when the person was talking about this, but there's, from my perspective, a balanced state where this different handedness flops kind of cancel out and just leave this constant value. And all of this is literally what I was thinking, except I just think that the Higgs field idea is wrong. The Higgs field and the Higgs particle, the Higgs field is just dark energy, which is what I said the particles are breathing in and out. And this changing of handedness is just, as I said, breathing in and out, the taking in of energy and then the sending out of energy. And overall, it, keeps it as at the same value relatively, but it is, cycling back and forth. And this cycling back and forth is, how it creates energy and mass, and it maintains its mass and its energy. And so I was like saying all this stuff, and I'm thinking I'm out here completely coming up with new concepts. No, we already have all these concepts. They already exist. I'm literally just saying what already exists, except I'm just defining it in a way that, in my opinion, makes a lot more sense and is a lot less woo-woo mystical. We don't know what's going on. No, we do know what's going on. It's not as complicated as you're making it out to be. We don't need all these random particles to make all this work. The particles can do it themselves. And you may say, no way, man. And I say, yes way. The Higgs field is just dark energy, as I said. Mass comes from absorbing energy from dark energy or interacting with the Higgs field. The larger flavors swap or interact faster because they are a different phase of matter. Gases move around more and faster than that of solids or liquids. 3 flavors, 3 phases. That's why we only see the large ones in particle colliders. It's too cold for non-solid states to stick around. Neutrinos, however, are so small that it doesn't take much to freeze or thaw. And so it's constantly changing back and forth as it gains and loses mass from the dark energy that surrounds everything. Again, that kind of goes into like how hard it is to freeze hydrogen, because hydrogen is like such a small thing, it kind of chills as a gas. You've really got to get it super cold to make it a liquid, and then I don't even know if we can make it a solid. Maybe we can make it solid if we really try, but I don't even know. But that kind of goes into what I'm saying is that, like, hydrogen is really small, so it doesn't freeze easily. So too is neutrinos, except it's just really cold, right? Compared to what the universe used to be, right? It's really cold. And so we only see the solid states of quarks, but and all those other particles, but they do have those other states. They just no longer are possible because of how cold it is. And neutrinos, on the other hand, are like, guys, listen, the water's fine. And they just kind of bob in and out, and they do their own thing. We also see, and again, like all the particles are getting their energy from, dark energy, which is, if you really think about how much empty space is between us, neutrinos can fly through the whole planet, no problem. Like, that's a lot of empty space, if you're asking me. So, in that empty space, these neutrinos are interacting with, this Higgs field. They are, in my opinion, they are interacting with the Higgs field. We just, but the Higgs field is dark energy, and it doesn't work how we think it works because it's not a field. It's just a fluid, and just like you shoot neutrinos through water, that's how we get them to react with stuff, or how we get to observe their reactions. We send them through a liquid, right? And dark energy is really just a liquid on a different energy level, but so it's flying through this, and it interacts with particles as it goes, and builds up an energy, and then after it builds up an energy, then it kind of cools back down, and then it heats back up again, and it goes back and forth because, again, as I said, all the particles are breathing, and so this quote-unquote breathing is what we're seeing the neutrino oscillating, because it's so small, its difference in mass or energy is significant when we observe it. But for the other particles, their mass is a lot larger, so this difference in energy for them is relatively small and doesn't necessarily appear as mass the same way that the neutrino's mass seems to oscillate, right? Its energy / mass seems to oscillate at a greater amount. It's really not oscillating by all that much. It just seems like a lot because we found it to be really small. I'm just kind of rambling, so I'm going to move on. We also see these cycles on a greater scale in our sun with solar maximums and minimums. This ties the very large to the very small and shows that this is not a new process. We already know it exists. I just recently I've heard the term solar maximum, but I didn't really know what it meant. But basically, our sun goes through cycles of it gives off a lot of energy, right? It has points of high activity where it gives off a lot of energy in solar flares. And then it has points of calm and quiet where it doesn't really do a whole lot. And to me, that seems an awfully lot like what I'm talking about with this breathing in and out. Why does it do that? Well, I don't have all the answers, but I believe it's for the exact same reason that particles do it at the small scale. And, basically, if you really want to think about it, relatively speaking, I think that the sun could just be a very large particle, and what we think are very massive objects are tiny little specks. And, that's why everything should be observable at the very large and the very small, because, theoretically speaking, there's no difference. And if we were, larger in size, where the cosmos was basically nothing, right? The entire universe could fit between your fingers, right? Then all of a sudden, the sun is just some photon, emitting light. And so it no longer is mysterious why it's doing that. If they're both doing it, they should both be doing it because they're both the same thing, kind of. And I know that sounds crazy, and I know that's like, what are you talking about, bro? Particles are not the same as the sun. The sun is made of particles. It couldn't be a particle. And I think that you are blind, and you need to kind of, look around a little bit. So I'm not saying I'm 100% right here, but I'm saying it's more likely than not that that's the case. Anyway, moving on. I think that's all I had to say in this one. So, yeah. Peace out.